So statistical inference is the name of the game. And we're going to start by looking at a topic called sampling and estimation. So make sure you're paying attention. We're going to define a few words to start with. Population is the first thing we're going to look at. Now, this I'm hoping is slightly a revision of work that you've done in previous years. But if you remember, population doesn't refer to the whole world or Australia necessarily. It really refers to, well, what group is the group that I am trying to find information about? Everyone that belongs to that group would be a member of the population. Okay, so it's very context specific. So population is the set of all eligible members of the group. So if I was doing a survey of this class and I wanted to know how this class is, you know, maybe it was my teacher evaluation form or something like that, then if I wanted to get like as accurate information about this class as possible, I would survey the entire class. So if you are a member of this class, you are a member of the population of my survey. Does that make sense? And maybe rather than giving you a Google Forms survey to fill out, maybe instead I want to have a half-hour interview with you. Now, there are 16 students in this class. That would be 8 hours of interviews for me to do. That's not going to be possible in a short time period. So what I do instead is I pick a sample and say, I'm going to select a sample of this class and use that sample to represent the population. Okay, so a sample is a subset of the population. It is used to make inferences. I'm inferring. I'm going to extrapolate from that particular sample an idea about what's happening in the whole population. So I pick my sample, I do a half-hour interview to get real detailed information about my performance in class so far, maybe. And then I say, well, I'm suggesting that that sample of 6 students, for example, that's 3 hours, I can do that, is representative of the population. Okay. So I do that, and I need to come up with a method to come up with those samples. So I say, you know what I'll do is I'll just interview all of the people who identify as males in the class. Or I say, I will interview just the year 11s. That'll give me a smaller group from which to work. A very small group. Or I say, just the people with green eyes. You know, I've got to have something to give me a smaller set, right? Something has to happen in order for me to get that smaller set. So I pick a characteristic and I go with that. Is that okay with everyone? Shouldn't be. Yeah, but don't think too mathematically at this stage. We're just talking about picking a sample. It shouldn't be. Why shouldn't it be? Based upon the 3 examples I gave you. For example, Sophie, are you happy that I am explicitly excluding you from the group because you don't identify as male? No. Well, you might be happy for the wrong reason though, because you don't want to be interviewed. But you know, that's weird. I think if I deliberately said I'll just choose the year 11s, what's wrong with that? Yeah, and the year 10. Is it representative of the population? Not as, particularly not in this class. It's not representative. People who have green eyes. I think it's probably the best of the three, but still, what happens if there's only two people who have green eyes in this class? That kind of thing. So, and also, if you've got blue eyes or a different color eye, you may feel excluded as well, right? So, it's not necessarily great. So, the sample is only useful if it is representative of the population. Does that make sense? So we need to get it representative somehow. Now, I just want to pause for a moment and just talk about. I'm not too sure how they do it in the age of streaming, but it always amazed me how organisations like OzTam, which is like the Australian organisation which which comes up with those how many people watch the AFL Grand Final and stuff like that. Now, they say 2 million people tuned into the Grand Final. Now, they did not survey everyone in Australia to come up with the 2 million. Okay, or 2 million, yeah, or however many in Sydney, or however many in Melbourne, or whatever else. How it used to work, and I don't know how it works with streaming services, but how it used to work is they would put a set-top box, a little set-top device on a certain number of televisions, so that when people were watching TV, it would collect data about what they're watching, and that gets fed into a big database, and then they're able to come up with their figures. Now, they don't have like millions of set-top boxes out there or set-top devices. What they have is a sample set. And organisations like OzTam are so good that they are able to select, using sophisticated algorithms, the right number of boxes in the right suburbs, in the right houses on the street, to be representative of the population. It's amazing. Like, it's in the thousands, but when you're reporting on numbers that are in the millions, that's quite amazing how they can do that. And they can do it with a really high confidence interval, and we'll do that later on as well, which means that they have a low margin of error. So when they collect that data, they can say with 99% confidence 2 million people watched the AFL Grand Final or whatever. And they need to be that confident because the people relying on the data who are paying them to have reliable data are advertisers and stuff like that. And so if the advertisers weren't confident with their data, then they wouldn't be paying OzTam to come up with the numbers in the first place, kind of thing. So it's big money, and getting samples right is a really complex kind of thing. Guess what? We're not doing anything complex. We are doing a simple random sample instead. So a simple random sample it simply means this. Every member of the population has an equal chance of being included. So even if I went for, I'll just choose the people who have green eyes, then that's not really a simple random sample because I haven't randomized it at all. I've picked a particular characteristic. Okay, so how do we do that? There's a few ways we can do it, but I just wanted to show you really quickly. Here is an example of, here's our class. Let's just say I want to choose 6 people for my survey. Okay, so here's the list in alphabetical order. Quite simply, I can go to the blank cell here, and if I type in equals rand, bracket, gives me a random number. And then if I fill down, like so. There's my and every time I type something in, that random number changes, by the way. So it's randomizing every single execution. And then I select the list. This is, see how lucky you can be, whether you're going to be selected or not. And it's the same in Excel, but just slightly different locations of where you do it. I can sort according to column C. I'll do it in ascending order. So that's from A to Z, means smallest to highest number there. And there we go. I've now got the winners are Charlie, Darcy, Gabe, Lucy, Charlie, and Pip. I would pick you to do the interview, go through the interview process. By the way, you get a $100 gift voucher for being part of it too, so that's good. So you would be the 6 people. But if I regenerated the list, if I need to get another 6 people for another reason, I just regenerate the random numbers and then grab it and then sort it. And then the winners of the $100 gift vouchers now are Lucy. You're up a lot now, $200. Charlie as well. Emily, Monty, Tian, Sophie. So it's a different. It could be the same people, but it's definitely a different 6, even if some of them are the same. That kind of makes sense. So this is pure randomness, which is what we want for a simple way of determining a sample from our population. Okay, questions yet? No. Okay, cool. So that's how we would do it. In your textbook, it shows you how your graphics display calculator can do the same thing, but I would just use a spreadsheet every single time. It's too easy to do it. Okay, 2 last things to look at, and I've got 4 minutes in which to do it. But remember, I will support this with videos of how-tos. So population proportion, what does this refer to? The proportion of individuals in the entire population who possess an attribute. This is a constant number because the population is constant. Okay? This is a constant number. Now, normally the attribute that you pick is a binary attribute. Okay? So the attribute is usually binary. Now, if I chose gender, for example, that doesn't mean that I have to consider, that I have to therefore say gender is binary. All I'm saying is what I'm looking for is binary. So, in other words, if I am looking for example, the people who identify as female, then it's binary because either you identify as female or you don't. I'm not saying male or female. I'm saying female or you don't identify as female. Does that kind of make sense? That's what makes it binary. Okay, it's one or the other. Okay? So the formula for that, it's really simple. We call it P for the population proportion, and it's the number in the population with the attribute all over the total population. So for our class, for example, if I said I'm looking for the proportion of people who identify as female in our class, I would be going 1, 2, 3, 4, 5, 6. So, e.g., in a class of 16, there would be 6 that would possess that particular attribute. Okay? Which you could then simplify to 3/8. Sample proportion, and I've only got a minute left. I might need to just take another minute more than that. Sample proportion is the proportion of individuals in a sample. So it's the same idea, except that it's from the sample instead of from the population. This varies because I can keep on taking different samples, and each time I take a sample, I'm going to get a different proportion. That's not necessarily a bad thing. It's a thing to consider from sample to sample. I'm going to really quickly finish up here. So the language we use, we don't want to use P again. It's kind of related to P, but it's not. So this is the language which you will come across in tests. It's not just Richard's special one. It's P with a little hat on top of it, and you literally call it P hat. P hat. P hat is equal to number in sample with attribute over the sample size. E.g., P hat is equal to, so I'll just really quickly show you, I promise I am finishing up. So P hat, according to our spreadsheet here, I won't randomize them again. I'd be saying the number of people that have the attribute 1, 2, 3. So I've got 3, and the sample size was 6, and so we end up with P hat equaling 3/6, which is 1/2, which I'd say is pretty representative. It just happens to be representative of the population proportion as well. Okay, so they sometimes might be the same number, but very rarely they are quite different. That's it for